Hello guys, in this session we speak about plotting in Python. You learn how to plot different types of plots, for example, line plot, bar plot, scatter plot, join plot, box plot, histogram, animated plots, and different types of cat plot. We use in this session Matplotlib, Seaborn, and some other libraries. Firstly, you should download this data: London Borough Profile 1 CSV, MyPub CSV, SAR data CSV. Then we open our Miniconda, activate our environment, then open Jupyter Notebook. We open Jupyter Notebook file, plotting in Python, because in this session we create different types of plot. We use a list of packages, so these packages should be installed. After that, we import these libraries and functions. For example, import re, import seaborn as SNS, import numpy as np, pandas as pd, random, matplotlib as mpl, matplotlib.pyplot as plt, matplotlib.cbook as cbook, pandas data reader as pdr. From Pylab, import functions. From mpl toolkits.mplot3d, import access3d. From matplotlib.colors, import listed color map. The first type of figure we create is time series, starting with the one variable time series. Load the time series data from GitHub. We name it df. The data is a10.csv. Then we define tplot function. Div, define tplot, df data x and y, title, xlab, ylab, dpi of resolution. plt.figure, the size is 16 by 5. dpi, we defined it before. plt.plot x, y, and marker, the type of line, and the color of line, blue. plt.gca.set, title, xlab and ylab. xlab date, ylab is value. Then we create tplot by using df, the data, x index from data frame, y value from data, then the title. After that, we use plt.show to display our result. That's one variable timeline from 1992 to 2008. In ylab, we have value. Then we have seasonal plot of time series, starting with loading data, then prepare our data, df year, df month, years equal df year dot unique, then prepare colors, np.random.set 50, my colors equal np.random.choice, list from mpl, we select colors, then draw the plot by using plt.figure, selecting the size of figure and resolution. For I and y in enumerate years, if I greater than O, plt.plot, month and value, color equal my color is I, change the color, then we select the text, font size 12, color, my color is I, change the color, then we have decoration by using plt.gca xdim minus 0.3 to 11, ylim 2 to 30, y level, drag cells, x level, month. Then select plt.y text, font size 12, alpha 0.7, then plt title and font size. Finally, display the plot by using plt.show. That's our result, seasonal plot of time series. In ylab we have drug sales. In xlab we have months from January to December, and we have different years presented in different colors. Another type of time series is plotting two variables of time series. For creating some data, r is equal np.random state 365, value equal rs dot randn 365, 2, date is equal pd pandas dot date range, period 365, and frequency is day. Data equal pd dot data frame, value, date, columns A and B. Then sns dot line plot, we use Seaborn library, the line plot function from Seaborn library, then selecting data, palette, tab 10, and line width 2.5. That's our result. We displayed two variables A and B in the same plot. In Y we have the value, in xlab we have the time. The next type of plot is heat maps. Starting with the load an example of dataset. We load flights dataset from Seaborn library. Flights underscore long equal sns dot load underscore datasets. Selecting flights. Then flights equal flights underscore long dot pivot month, year, and number of passengers. Then for draw a heat map, we use f comma ix equal plt dot subplots, figure size 9 by 6, sns dot heat map, data is flights, a not equal to true, line width is 0.5. That's our result. We have different months and different years with the heat map in different colors. Then we have swarm plot by using Seaborn package. Importing CSV data, which is London Borough profiles 1.csv. We name it df. We create data frame. Then cleaning our data by change name, some long name of columns. For example, df.rename columns inner outer London to in out, happiness score 2011 to happinesses, and so on. Then we create data frame 1, which is include diabetes, happiness, and anxiety. Data frame 2, which includes in out, employment, happinesses, and anxiety. To create swarm plot, we use sns.swarmplot data equal df1. Then to select x and y labels, we use plt.gca.set y label equal value, x label equal index. That's our result. We have value and diabetes, happinesses, and anxiety. The next type of plot is bar plot. We use Seaborn sns.barplot function, data equal df1, the same data, and selecting x and y level. That's our bar plot value, and we have diabetes, happiness, and anxiety with the error bar variables in different colors. We have stacked bar plot. We select labels A, B, C, D, and E. Men AV average these numbers, women average these numbers, then standard deviation of men and women, and width 0.5. Fig, comma, BA equal PLT dot subplots BA dot bar labels from A to E, then men average, width, then we have women average and width, level equal women, BA dot set Y level scores, ba.set title, scores by group and gender, then create ba.legend and display our figure by using plt.show. That's stacked bar plot. We have women and men in the same bar in different colors. The next type of plot is pair plot. We use Seaborn sns.pairplot and the data is data frame 2. That's our result, pair plot. Then we have scatter plot. Also we use Seaborn sns.scatterplot data frame 2, X employment, Y happiness, plt.legend, log equal 8. We have happiness and employment. U is in out, the blue color inner London and the orange color outer London. Then we have 3D scatter plot, sns.set underscore style, white grade, access.grade equal false, figure equal plt.figure, x equal access 3D figure, create x, y, and z data by using NumPy. Because it is 3D also we need z. Then we get color map from Seaborn. We name it CMap. Then G equal x dot scatter by using x, y, and z. C equal x, S equal 50 marker. Then the color we defined here. Then alpha equal 1. Then we set x, y, and z labels, x level, y level, and z level. Then added a color bar, fig.color bar equal G, shrink equal 0.5, and aspect equal 5. Finally display our figure by using plt.show. That's 3D scatter plot. Then we have scatter plot by varying marker colors and sizes, evaluate data, day, ji, and stuk. Then we get the most recent 365 days data. Then getting the price of close day and the price of day before. Set a color of 363 days from Seaborn color palette library. Then get set of colors 363 days from Seaborn library, which is color palette. Colors equal sns.color palette. Set 363. Plot in scatter plot. Fig, comma, pl equal plt subplots. pl dot scatterplot delta 1 minus 1, comma, delta 1 1 color equal colors, s equal volume, and alpha 0.5. Then set xy labels and title, pl dot set x label and font size, pl dot set y label, selecting title, pl dot grade true. Then set xy limitation, pl dot accesses for x lim and y lim, pick dot tight layout, then display the result. That's our result. Scatter plot in different colors and sizes. Then we have joint plot. Besides show the relationship between x and y, it displays the distribution of x and y. We create x and y, then sns.joinPlot x equal x, y equal y, kind regression, plt.gca to set x and y level. That's our result. Then we have pie chart, creating some data. We name it A, B, C, and D. The value, for example, 5, 15, 30, and 50, using plt.py values, labels equal names, level distance equal 1.15, shadow equal true, start angle equal 90, then display our result. That's our pie chart. Then we have box plot. The data is sar underscore data CSV. We use Seaborn sns.boxplot function. Data equal df. We select palette M and G. sns dot dspine offset equal 10 and trim equal true. Then selecting X and Y level. That's our box plot. We have value and type of sensor next, which is PHH, PHV, MHH, and MHV. Then we have histogram, create some data, we name it bio. Then we use Seaborn function. Then we use Seaborn library, sns.setStyle, dark grade, to set the grade style of the figure. Is equal sns dspplot, data is bio, x level value, font size 12, y level frequency, font size is 12. That's our histogram. Then we have animated plot in Python. We have two examples. The first one, I display my citation and number of publications. The data is mypub1.csv. For I in data.year unique, plt.iof, turn interactive plotting off, initialize a figure by using fig equal plt.figure, figure size 10 by 6, then find the subset of the dataset for the current year, then build the scatter plot, plt.scatter, x equals subset data, cumulative publications, y subset data, cumulative citations, s equals subset data, cumulative citations multiplied by some number, for example 15. That's for change the size of plots. Edge color is equal white, line white is blue, and color midnight blue. Added titles plt.yscale linear, x level publications, y level citations, and the title publications and citations during each year, selecting xlim and ylim, then save figures. For example, in my desktop, I have test folder and the style of figures PNG. Selecting resolution and file name DPI equal 96, then plt.close figure. Now we go to our folder in desktop. That's the results. We can convert this PNG, a list of PNG, to GIF. For example, online, we can go to this website, upload images. We select images, then open. Now our image is opened. We click on create GIF animation, then download the GIF. We go to downloads, then open our result. Now we convert PNG to a GIF, which display my citation and number of publications from 2015 to 2021. The next example is animated scatter plot. The data is gapminderdata.csv. Set the figure size plt.figure, figure size 10 by 10, for example. Subset of data for year 1952. Data 1952 equal data. Data.year equal 1952. Image resolution DPI equal 96, for example, for each year. For y in data.year unique, plt.iof, turn interactive plotting off, then initialize figure, fig equal plt.figure, figure size and resolution, then find the subset of dataset for the current year, subset data equal data, data.year equal I. Then build the scatter plot by using plt.scatter, x subset data life expectancy, y subset data GDP per capita, then S population, C subset data continent.cat.codes, CMap, we use accent, alpha 0.6, edge colors white, line wide if equal to. Adding titles, y scale log logarithm, x level life expectancy, y level GDP per capita, plt.title year equal plus stri, xlim 30 to 90, then save figures as png inside my test folder in desktop. Then we select resolution and file name, which is we defined before, then plt.close. Now, in the same way, we can go to our desktop. That's our PNG results. We can convert them to the GIF in the same way by going to this website, for example, open figures, then click on create GIF animation, then download the GIF. We go to download folder. That's our result. We converted PNG to GIF, which display GDP per capita, and in X we have life expectancy, the size and color of plots different, and it changing by year. The next type of plots are categorical data, cat plot, categorical plot. For example, if you have variables divided into discrete groups, it may be advantageous to use cat plot. You have different types of cat plot. You can change them by changing the kind to, for example, violin, swarm, boxing, strip, box plot, point, bar, and count. The first one, violin cat plot, starting with the load titanic.csv file from Seaborn library. Titanic equal sns.load dataset Titanic, then G equal sns.catplot, X equal P class and Y equal age, U equal alive, data equal Titanic, and kind equal violin catplot. Legend out equal false to move the legend to inside the plot. Then plt.legend title equal alive, location equal 1 means upper right. That's violin catplot. Alive, yes or no. Passenger classes from 1 to 3. And we have age in Y-lab. In the same way, we have swarm catplot, the same data. Only we change kind to swarm. With the plt.axis, we select xlim and ylim. plt.legend to select title and location. Location 9 means upper center. That's our swarm catplot. Then we create boxing catplot, kind equal boxing. Then strip catplot, kind equal strip. That's our result. Then box catplot, kind equal box. That's box catplot. Then we have point catplot, change the kind to point. Then we have bar catplot, the same data, only we change kind to bar. That's bar catplot. Finally, we have count catplot, kind equal count, differentiated by 6. That's count catplot.